Number 83, right? Correct. Okay.
Oh yeah, I forgot about that. Dude, I am so ready for Locust.
I've been looking forward to it all day.
Ready for what?
Locust.
Brian or Diego, one of y'all needs to join us on that.
Locust?
Locust, you got it?
Locust.
Was that new, Mr. Townsend, or did we just not seen it before?
Get what?
Locust.
Oh, yeah.
Oh, yeah, I've had it.
What is the locust?
What's that?
Wouldn't it be Glaucus?
We could like put stainless with flavor.
I mean, it's blocks. Wouldn't it be
I
Glaucus?
said you could just put stainless with flavor.
Yeah, that's actually what I was saying yesterday or Monday.
Yeah. I mean, for the time being, if we get 3D printing, that would be like 10 times better, but just for like more.
Does it maybe not look at 3D print? So you're in the,
I signed up for the Mario Kart thing. Let's see how I do.
Yeah, do that.
Yeah.
Just make sure it doesn't throw any shade at you. This morning, he has this club in my advisory, and there's this guy, and he just throws shade. So much shade, it's not even funny.
Hands pretty guy, dude.
Like literally this entire group, they all work under this one guy, and he just throws so much shade. My God. He's like, you know what this is? It's just like, yeah, he's like, oh wait, you do?
All right, if you did not turn in number 80, section 1.9 worksheet, I need that from you in the basket before we get started here. Also, you're welcome to use a calculator, but I don't think a calculator is going to help much. So.
Yes, sir.
Yeah, you got it?
Yes, sir. Thank you.
Are you cut it? I need to come in and ready by the
Sorry, I was sick all of my. Thank you, sir. Thank you so much, sir.
Is this what we get different from what the grads Jesus Christ, sorry.
Next Tuesday,
Hello.
Mr. Townsend.
Good, how about you?
I was good until I came in here realizing that book or something I hadn't.
Tomorrow.
If you missed the Monday, you should be caught up by Friday. Oh wait, tomorrow's Thursday. Tomorrow or Friday.
Okay. I guess I'll get out of band Friday. Yeah, I'll get out of band Friday because it's not.
You ready?
The quiz?
Yeah.
Over inverse. I'll have to look over something. What was the assignments?
I sent you the video of class. That's the best I can do.
Okay. The worksheet's over here, correct?
Oh, so I don't need this. Yes, I do.
And you need to sign up for prime time on Thursday or Friday.
Yes.
Okay, so pretty short. Our quiz is number 81. You are welcome to use a calculator, but I just don't think a calculator is going to really do anything for you. Just so I don't forget, if you are interested in doing the ACTM, the math contest, that is Saturday morning, March 3rd, March 4th, whichever one of those is Saturday. You do not get signed up until you turn your money in, which is $5. I will be submitting that money to someone on campus Friday at lunch. So if you want to do it, that would be great, but you need to make a plan to bring me your money after class today, sometime tomorrow, or sometime Friday morning. It's not realistic.
I'm signed up for tomorrow.
And then use this time to get cut.
You'll need to wait for the pass to come back, but he should be back in a second. Alright, is anybody still working? Okay, then let's move on. So you should have picked up 2 new handouts today. Both of these are over section 3.1. So we're jumping ahead a bit. 1.9, a little bit further back in the textbook. But our next 4 sections that we will be working on is 3.1, then 3.2, then 3.3, then 3.4. So 3.1 is specifically about exponential functions, what we're going to be looking at today and Friday. And then 3.2, 3.3, and 3.4. Some of that we'll get to before spring break, and some of it will come after spring break, but all of that is over logarithms. So the first one we're going to look at today is 82. So that's where we're going to go through some notes and give you some reminders. Just like the inverse functions, I hope that most of it sounds familiar to you, but we understand that you may have forgotten some of it. But whether you're doing calculus or college algebra next year, you need to know those. Then 83 has a worksheet 1 on the front and a worksheet 2 on the back. We're going to do worksheet 1 together, and then worksheet 2 is going to be your homework. But I'll try to give you enough class time that you can get most of that done. So, alright, so to work with exponential functions, we need to know what it is, what they look like, and some exponent rules, and some stuff like that. So to start off, what is an exponential function? That's anytime you have a variable that's up in the exponent. And so with exponential functions, you often have exponential growth and exponential decay. Growth is when your base is bigger than 1, like 2 to the x or 3 to the x. And decay when your base is less than 1, like 1/2, 1/3, 2/3, stuff like that. Now, realistically, you probably just want to know what these graphs look like to save yourself some time. But worst case, and we'll pretend like we just don't know what these look like, just like any other graph, if you need to have an idea of what it looks like, plug in a few x values and solve for y. So if I start off with 1, 2 to the first would be 2. Plug in 2, you get 4. 2 to the third is 8. What about 0? What is 2 to the 0 power? 1, because anything to the 0 power is 1. I'm going to be saying that a lot the next few weeks.
Why is that?
I don't know. That's just the way it works. I'd have to think about it. Anything to the 0 power is going to be 1. Except for 0 to 0, that I don't know the answer to. But okay, what about something like -1? What is 2 to the -1?
Would it be 2?
It's not 2. If you have a negative exponent in the numerator, like this, you can move it to the denominator to make it have a positive exponent. So 2 to the -1 is the same as 1 over 2 to the +1. Now, of course, you can plug in points all day, but eventually you'll figure out what it looks like. Of course, it just helps if you know what it looks like to start off as well. Alright, the only difference with 3 to the x, not going to be a lot. You're still going to think about 3 to the 0. Anything to the 0 power is 1. 3 to the first. 3 squared. What about 3 to the -1? What does that equal to? Good, 1/3. -1 exponent in the numerator is the same as a +1 exponent in the denominator. Same thing, you can plot points all day. That's really what your calculator does. Your calculator just plots hundreds of points and then makes it look like a line. But a couple things I need you to get out of this. Exponential growth questions look like this. They're going to go up over time. If you're reading left to right like you do a textbook, it's going to go up. And then also, notice how similar these graphs are. Whether you're talking about 2 to the x, or 3 to the x, or 5 to the x, or 10 to the x, or e to the x, they're all basically going to look the same. I mean, some of them are going to rise a little bit quicker, Some of them are going to hug this x-axis a little bit quicker, but the general shape of all exponential growth graphs basically looks the same. Okay, if we did the same thing with this and we plotted in some points, anything to the 0 power is 1, 1/2 to the first would be a half. What about 1/2 to the -1? What do you think that's going to be? Good, that's going to be 2 because of exponent rules. I've got the exponent rules typed up on the next page. But essentially what ends up happening is it ends up just being a y-axis reflection. 2 to the x and 1/2 to the x are just y-axis reflections. But what I need you to get out of this one, based on what we did in questions 1 and 2, if all exponential growth graphs basically look the same, all exponential decay graphs basically look the same. So 1/3 to the x, 1/5 to the x, 1/10 to the x. They wouldn't look exactly the same, but they would be pretty close. And that it's decay, so it goes down over time. Now, those are some pretty basic graphs, so of course we're going to make some changes to them, and we're going to do that with transformations. Same transformation rules that you've seen since Algebra 2, maybe even Algebra 1. We even reviewed these last semester when we graphed trig functions. But if you add something to your parent function, it's going to go up that much. You subtract it from your parent function, it's going to go down that much. The next two are the ones that are not intuitive for everybody, but if you add directly to x, it goes left, and if you subtract from x, it goes right that much. If you multiply the entire parent function by a negative, that's how you flip it over the x-axis. And if you only multiply the x by a negative, this one you guys sometimes forget because you don't get to use it as much. If you only multiply the x by a negative, that's how you flip it over the y-axis. And that's why 2 to the x and 1/2 to the x look the same but with a y-axis reflection. Okay, the next page is mostly done for us, but I wanted to quickly talk about some of the stuff we're going to need to look at. So on the left we've got an exponential growth, on the right we've got an exponential decay. It's actually two equations that we just graphed on the other page. So once we practice graphing these a little bit, we want to be able to answer basically everything about these graphs. So we will ask things like, what's the domain? And domain is a way to describe the x values that the graph hits. Since he goes forever to the left and forever to the right, the domain is everything. Range is a way to describe the y values. He goes as low as 0 and up forever. That's why his range is 0 to infinity. He's got a y-intercept at 1. This graph is increasing all the time. It's tempting to think that this is a vertical asymptote, but realize that this does keep going to the right very slowly, but it does keep going to the right. So there is no vertical asymptote on these graphs. When we do logarithmic graphs, it will have one. That's just not this section. And he has a horizontal asymptote at y equals 0. So right here, the further left you go, the closer the y values get to 0. And then you can do the same things with this graph. Domain still hits everything. Range, it's hitting the same y values. Y-intercept, still at the same place. This one is decreasing instead of increasing. Still has a horizontal asymptote at y equals 0. It's just on the right side of the graph instead of the left side of the graph. But if you can graph these and you know what these are asking for, then they're not anything that I think you need to like try to memorize or anything. One other thing I want you to get out of this page is some of these exponent properties, because this is tough. When I taught Algebra 2, this would be something we could do one day. Everybody'd be on board, everybody felt comfortable with them, and then the next day we'd use them and people would forget half of them. So this is the way it goes. So what I'd like you to do is I want to go ahead and explain each of these, maybe throw out a few examples, and you should just put a star by the ones that you think you might want to look back at before we get to a quiz. So this one has come up 2 or 3 times already today. Anything to the 0 power is 1. This has come up once or twice already. If you have a negative exponent in the numerator, you can move it to the denominator and make it have a positive exponent. Or if you have a negative exponent in the denominator, you can move it to the numerator to give it a positive exponent. Caroline, you need to put that up. Now it's not the time for that. And then another example of this. Are you guys okay with those? Okay, on the left, this is the one that you probably use the most, because what is x times x going to be?
X squared.
So when you multiply things with the same base, you're just adding the exponents. That's what you're doing when you say x times x is x squared. So if you divide things with the same base, you should subtract the exponents. So sometimes you might think of it as like 2 of these x's cancel out 2 of those x's and leave you 1x, but you're really subtracting the exponents. 3 minus 2 gives you 1. If you take a power to a power, the powers end up getting multiplied. So imagine x cubed squared. This would be like x cubed times itself twice, which would be x to the what?
6.
So in the end, you really just multiply these two. And if you raise some stuff to a power, then everything gets raised to that power. All of this gets raised to the power of m, then x gets raised to the power of m, y gets raised to the power of m. Raise 2x to the third power, 2 gets raised to the third power, x gets raised to the third power. So again, I know all that can seem familiar if I'm just saying it, but you should put a star by the couple that you think you may need to look back at. It's the ones you didn't remember without me bringing them up. That's what you need to mark out of that. Okay, and then to just be truthful with you guys, exponential functions and for a large part logarithmic functions, most of those applications in the where you're going to use those if you pursue a career in math or science is going to be in science courses. Exponential functions and logarithmic functions mimic a lot of real world type stuff. In math class though, at least with exponential functions, we're only going to ask you to be familiar with 2 of them. One of them is on compound interest formulas. These 2 look familiar from Algebra 2?
Yes.
Okay, and I think these used to be on the ACT all the time. I don't know if they still are, but it used to be a big thing on there. So if you've not seen that on the ACT, I still wouldn't be dismissive of it. But within these, you got to memorize both of these formulas. They do 2 different things. One is if you're compounding continuously, and one is if you compound a certain number of times per year. Christian, please stop. But both of these formulas have a P, so you need to know that P is for principal, which is the starting amount. So that could be how much your loan you're taking out, or it could be how much you're investing, just whatever your starting part is. Both of these formulas have a T, which is time in years. So if you had a 6-month loan, T would just be a half. Both of these have an R, which is for rate. And this one is important that we put, it needs to always be a decimal. So if you were told the rate was 25%, you would actually put 0.25 in for R, not 25. Then the last 2 just depends on which formula you're using. If you're doing compounding continuously, you've got E. E is not a variable, E is a number. It's about 2.718. Didn't this come up a few days ago, or was that a different class? It might have been different.
You mentioned it, yeah.
Okay. So second divide brings up the number E. It's not this E by sign. That's like if you're typing a message. So we would use that part of our calculator for compounding continuously, and if otherwise it's got N in it, this is going to be, N is going to be the number of times it compounds in a year. So it could say annually, which means once a year, quarterly would be what?
4,
Monthly would be,
12.
daily would be 365. However many times it compounds in a year, that's what you would plug in for it. So for the most part, you really need to know those two formulas. Again, we do ask that you memorize them. However, it should pay off on the ACT. And you got to know what these parts are so that you plug the numbers in the right spot. But then that's pretty much all you need to be able to do with that. Now, I do want to get on to the worksheet 1 and 2 so you guys can get most of worksheet 2 done in class, if not all of it. But I do want to take just a second here to kind of focus on this formula, because this one, let's say that you guys just choose to not do anything math or science related in your future. That's just not what you're interested in or whatever. This is probably still going to be the formula that impacts your life the most. So the quick little example that I'd like to give to you is, let's say someday you want to buy a house and you got to go to the bank and borrow some money. Now, first off, if you want to buy a house for a certain amount of money, they don't give you all the money. You have to like have a little bit of a down payment saved up. But how much do you think like the average home in Fayetteville would cost? That's way too much.
250.
Okay, maybe 200, maybe 250. So let's say that's how much you're asking the bank to borrow. That's your starting amount, that's your principal. The rate changes over time. My rate was 4.25%, then it went down for a lot of years. It's gone up recently. Someone, I think in my 0 hour, looked it up today and they said it was 6.25. The rate to borrow money. It's not per house, it's just whatever the economy is at right at the time. But how many years do you have to pay on a house before you own it and the bank doesn't own it?
12.
More than 12.
30 typically.
30 is a typical mortgage.
He has like 4 of them.
So,
What if you die before then?
30 years? Well, someone in your family could pay the difference, or the bank, it goes back to the bank if you default on your loan. That's why they're willing to loan you the money, because it's technically theirs until you give them all their money. Okay, so again, this is a lot of hypotheticals. Let's say you were hypothetically borrowing $250,000. Hypothetically, the rate is this, because I don't know that that's exactly it. Yes, Tyler?
What would happen if you moved while you're still paying off your mortgage?
If you moved?
Yeah.
Well, you would sell your house.
Right, would you still have to, like, would you buy a new house and pay that mortgage while you're still paying off the original mortgage?
If you hadn't sold your first house, yeah.
Oh, but if you sell it, it's like clean slate.
Yeah, so if you sell it to somebody else,
They have to pay.
they would get a mortgage through a bank. That bank would give you a big check, and a lot of it would go to your bank to pay off your mortgage, if not all of it.
Oh.
And that's part of what y'all should be kind of scared about with the house prices rising. Like if they keep rising and someday you buy a $400,000 house and the housing market bubble pops again like it did a while back, one day you might spend $400,000 on that house, and then next year it might be worth $200,000. And then if you move, you're gonna have to eat the cost. If you stay there long enough, the house value will eventually climb back up.
I
But
think a sleeping bag under a bridge is pretty nice.
okay, well you can do that. Okay, but you're borrowing $250,000. We're assuming this is the current rate, although that changes all the time, and you want a standard 30 years. How much do you think you're going to pay the bank by the time this is over?
A lot.
Too much.
Like $1 million.
Billion?
Wow.
1.6 million.
I'd rather keep that for 4 sleeping bags than for a family.
You buy a lot of sleep. 1.6.
Over 30 years, you will end up, your payments will amount to that. Now, one thing that you could do, there's a couple options here, is the bank will offer you a 15-year mortgage instead of a 30-year mortgage.
But you pay more each year, right?
Right, it's basically like you're having to do 2 house payments a month. So that's hard to do, but if you can manage it, instead of paying them 1.6 over 30 years, you pay them $638,000 over 15 years. So it's hard, but it'd be a tough 15 years, but you end up saving yourself $1 million in the long run. Second thing is, have you guys ever heard the saying like it's expensive to be broke or something like that?
Yeah.
It's because of stuff like this. If you have money, a $250,000 house costs you $250,000. You just hand over the cash and you're done. If you have some money where you can make these type of payments, then you're paying up a little bit. But if you don't have much and you're getting by month to month and you've got to stretch it out over 30 years, then you're giving up over $1 million that somebody else didn't have to give up.
Nowadays, that's like a 2 or 3 bedroom house, right?
So you
It just
have to-
depends on neighborhoods and stuff.
Not sure.
The other thing that you could do, let's say you want a $250,000 house. If you save up for a while and you save up an extra $50,000 before you buy it, which of course is not easy, $50,000 doesn't come around easily, but if you can, then instead of paying 1.6 million, you'd be paying 1.3.
1.7.
So you're saving yourself $326,000 if you can save $50,000 up front. So again, even if you do nothing math or science related, if you buy a house someday, a lot of your work life is going to be towards this stuff. So understanding how that works and how that number, the exponents there, the rate and the time, the rate's out of your control, other than buying in a time when it's down, is going to greatly impact your life. Yeah.
Wait, so if you don't have enough money to just straight up buy the house where it's regular cost, you gotta pay way more than its actual value?
Well, sure. Why would the bank give you money?
Like,
And then
like wouldn't you just
they're not your friend where you give them $10 and then they just expect $10 back.
Yeah, but wouldn't you just
Interest, right?
yeah, wouldn't you just raise up or mortgage, for the mortgage, wouldn't you just pay until you get the amount that the house is worth?
Why would they do that? That's
They want to suck everything.
They're a
they
business.
can.
And they're worried you can't pay it.
And also banks are taking on some risk. Like, you might buy a house and they may think it's worth it. Even if you stop paying it, they get the house. But then if the housing market busts and then all of a sudden the bank end up throwing $300,000 at something and they're getting the house back, but now the house is only worth $150,000, they lost money too. So yeah, they have to.
They're making a lot of money if they're getting $750.
But if
Well-
it was $250,000 like that equation, and you pay 1.6 million, you'd be paying 8 times the amount.
Over 30 years, yes.
Oh.
But you can also buy a cheaper house.
Imagine being 50 and you had the opportunity to be a millionaire.
This might be a terrible question, but what does the E do? Why do you need E?
Right?
E is just the base of the exponent. When you do exponential or compounding continuously,
Yeah. That's
it's part of how it's computed. It's
Okay.
similar to this if it's compounded a certain number of times.
Okay.
But
Yeah.
banks typically use this one because it's just a tiny bit higher than this one.
Yeah, I was gonna say there's.
Okay, so not to get too wrapped up in that, but again, the more money you have to borrow at the higher rate, the more time you need. You're talking thousands and thousands and thousands of dollars difference. Makes a complete change in your life. It's something that you guys need to.
That's a larger scale.
You don't just wake up one day and say, you know what, I'm going to buy a house next month. You guys need to be educated and know what you're doing there. And of course, cars are similar,
Start saving up.
but cars are,
Is there a
you're
problem?
not borrowing as much, and the loans are not for as long, so they're not as extreme. But if you got to borrow money, then. And the flip side, credit card debt is similar. They compound it monthly. They give you a monthly bill. So if you're making the minimum payments, the difference with a credit card is the rate's not 6.5%. If whatever you don't pay on your bill, it's something like 30 or 40%. It's crazy. They make a lot of money off of you if you're not careful with credit cards.
Everything's free if you run
So
fast
what
enough.
am I doing?
That's not true.
Everything's free if you run fast enough. Can you borrow a gas station? Start running.
Yeah, okay.
Do you think it's valid
Eventually.
to get a really stable job or have quite a bit of money and then just use a debit card?
I mean, that's what you do, right?
Well, a debit card's like cash. You can't spend what you don't have in the bank.
Yeah,
That's fine.
but it would probably be smarter to do that if you have enough money.
If you have the money.
If you had $5, the candy bar costs $1, and you have that $5, you can use one of those $5.
Now you can pay cash or you can pay debit. It would be the same thing.
Dean needs a hard time.
What I do is I try to buy everything on credit card, but I don't buy what I don't need, and I pay off 100% of it every month. And so the benefit to me is I get like 1%, 2% back from my credit card company
Oh, you don't.
Oh, they-
in rewards.
Oh.
Like the more you spend on your credit card, the more rewards they give you. The trap is if you don't pay that bill 1 month, they're going to charge you 20, 30, 40% interest on what you didn't pay. And then if you don't pay it the next month, then they're doing interest on what you still haven't paid, plus the interest from the last time, and it snowballs very quickly.
It's like,
So do
But
they give
if
you
you're
cash
will-
back to like entice you to spend more?
so it's just a
And then-
gamble every
But
single
then they get you.
No, because
Or-
they want you to use credit cards because they get money.
Okay.
Like if you pay for gas at a gas station,
It's like putting
Oh,
all
there's
of your eggs
fees,
in a
right?
basket.
yeah, they charge the gas station like 2% or 4% or something to do that for that convenience. So they pass on a little bit to you so that you use their card instead of somebody else's
Don't
card.
pay it, it'll be really bad.
Okay, let's move on because I do want y'all to be able to do most of this, but
Not borrow your credit card.
no. Half-Life is the other one that we're going to talk about, and it is all nice and typed up here. I'm not going to look at this example on this one because I don't think you need it all typed up like this. I think it'll look or make more sense when we look at an example. So let's move on to worksheet 1, and let's talk about what some of the questions may look like from your quiz. Now on Friday, there is one question type we're going to skip on worksheet 1, the front, and so you should skip that question on worksheet 2 until Friday. That way we're not rushing on it. And I've got one other question type I want you to get some practice on just because it's been a commonly missed question type. But the majority of what you need to know from 3.1 will be this. Now to answer all these things about this function without a calculator, because we should know what this looks like without a calculator, we really need to kind of have a sketch of what this graph's going to look like. So in all this mess, I would say 3 to the x would be the parent function. So we just graphed that on our notes, but we also talked about all exponential growth basically looks the same. So start off with that, and then if I plug the number in for x, the first thing I would do is add 1 to it. So what kind of transformation is that going to be? Okay, so try to make your sketch look like it's gone left 1. The next thing would be dealing with this negative out front. What is that going to do?
Flip it.
Cross X.
Okay, so let's try to make our graph look like that. And then finally, the last part, the -1, what is that transformation?
Down one.
So take this and try to go down 1. Now, even though this is quick and not super accurate, it's going to be good enough for most of these questions. So that's how I would suggest you start. Start with the parent function, make the first transformation, make the second transformation. There's the third transformation, make the third transformation. Now that we've got a visual of what this looks like, what does it look like the domain is?
Negative infinity to positive.
Right, it goes forever left and forever right. The range is describing the y values. Well, what y value is it approaching on the small side? Good, because it goes down forever. What y value does it approach on the higher side?
-1.
Very good, -1. I usually don't trust my sketch well enough for that, but that's why these previous steps should help you. The range here is 0 to infinity. You shift it left 1, it's still 0 to infinity. You flip it over the x-axis, now it's negative infinity to 0. And if you shift it down 1, now it's negative infinity to -1. So even though this is not super accurate, I can still walk myself to what the range should be. So it's still helpful. Okay, this guy had a horizontal asymptote at y equals 0. This guy had a horizontal asymptote at y equals 0. You flip it over the x-axis, it's still at y equals 0. But then if you shift it down 1, now it's at y equals -1. Okay, this kind of looks like a vertical asymptote, but again, it does keep drifting to the right just very slowly, so there is no vertical asymptote. Is this graph increasing or decreasing?
Decrease.
Good, it's going down over time. Now, one of my classes had not heard of concave upward, concave downward. Did you guys hear that in Algebra 2?
Yes.
I don't remember.
I don't, yeah.
Okay. So that's fine. We do a lot of stuff in calculus with concave upward, concave downward, but it's a little bit different. But concave upward just means the graph is opening up like a cup. This is concave up, and then concave down is when it's opening down like a frown. So ours is concave downward. Depending on what this graph's representing, we call that concavity. Concavity tells you quite a bit about what's going on. That's why we care in calculus. Okay, I'd like to know the order pair when x is 1. So here's my graph at x equals 1. I can tell it's negative something. Do we know what it is there?
We can put 1 in for that.
Very good. So probably not from this. That's too much of a guess. But we've got the equation. Plug 1 in for x and solve. You get negative 10. How should I find the y-intercept?
Plug in 0.
Good. It's the same type of question phrased differently. This one said, what is the coordinate pair when x equals 1? Y-intercept is just when x equals 0. Plug it. Don't look at your graph. Just plug it in and solve for it. And if your quick little sketch up here doesn't look consistent to that, if 1 negative 10 is not possible and 0 negative 4 is not possible, if you thought your graph was up here, then that would be a red flag that something was wrong and we may need to rework some of this. These should be correct. Okay, we already did the transformations to get our graphs. Plugging in a number for x, the first thing we did was add 1, so that's why left 1 was the first transformation. Then we flipped it over the x-axis. Reflect, and then the last transformation was down 1. I just didn't write it out in words, but I had already thought about that. We will not quiz you on J, but I do want you to know what this is. I do want you to write it in. I do want you to write it in on the back page. These are sometimes referred to as transcendental functions. The only time I think you might see that word in high school is if you looked at some calculus books. Some calculus books do early transcendental functions and some do late transcendental functions, and they usually put it on the cover. So that just means like they deal with the calculus of these type of problems early in the course or late in the course, early in the book or late in the course. Some people just prefer one way or the other. All right, K wants us to make a detailed sketch using A through H above. So that's going to be pretty easy because we already got 2 points, 1 negative 10 and 0 negative 4. We also have a horizontal asymptote. Asymptotes should always be graphed as dashed lines. And because I did myself a favor and made the sketch, I know what the graph's supposed to look like. It's supposed to look like that. I knew the shape of the graph already. And that's a pretty accurate graph. Now, of course, plotting more points would be better. I think on the tests, I think we give like a t-chart and specifically ask for like 4 points, but, or we have in the past, but you could do more if you need to. Okay, so then moving on from that, what are the 2 tests that it has to pass to be 1-to-1? Okay, is this one 1-to-1? Okay. Oh, I missed this. Sorry. This is on the bottom of your notes. I just went over it too fast. I want you to get, this is also one we will not quiz you on, but I do expect you to fill it out on the front and back of this since we went ahead and made a question. Euler's number, which is E, you need to know that E comes from 1 plus 1 over number, or no, I'm sorry, you don't have to know this, but I want you to know where it comes from. So as that X value gets bigger, that's naturally where that 2.718 number comes from. Just like pi is not just some number that someone said, let's make these decimal important. Pi actually comes from something. What does the number pi come from?
Circumference over diameter.
Good. No matter how big your circle is, its circumference divided by its diameter is pi. That just naturally occurs a lot, and so pi gets used a lot. This relationship naturally occurs a lot, which is why E naturally gets used a lot. Okay, part A here, this is the part we will do on Friday, and we'll do this plus a couple more questions because those take a little bit more practice. Part B, compounding formulas. So we talked about if it's continuous, that is the PERT formula, and if it's compounded any other amount of time, some students call this the print formula because it kind of looks like the word print scrambled up, but that's not really a math thing. And then you need to know how to plug these things in. So read through the question and tell me, what do you think P should be? 2,000, that's your starting amount. What do you think E should be? Or I'm sorry, R.
0.065.
Good. That needs to be typed in as a decimal. Both formulas need R. What do you think T should be?
365.
T is the number of years.
Oh, 30. My bad.
Both formulas need that. So if it's compounded continuously, there's your answer. Some years we make this no calculator, multiple choice, so you would just select that. If we did give you a calculator, we'd expect you to type it in and get a decimal. The only difference is if it's compounded not continuously, you also need to think about this n value. If it's compounded daily, how many times a year would that be?
365. Well, what about leap year?
Yeah, a bank might actually do 365.25, I'm not sure. But so as multiple choice, no calculator, that's what your answer would be. With the calculator, we'd expect you to type it in and get a number. Now, to be honest with you, I'm not going to take the time to type these in. But again, this works both ways. If you're investing $2,000 and somehow you can find someone that gives you 6.5%, although realistically you guys are going to get like 2.5% maybe. If you can sit on that money for 30 years, I don't know, it's like 12,000, 20,000 something. Like it's a lot more, but you've got to also not take it out for 30 years. That's a long time. And then if you do it daily versus continuously, it's like $3 difference. There's not much difference between them, so very similar. Okay, and then the last one, which I did not go over this in the notes with you because it's all typed up as a resource if you need it. I don't know hardly anything about chemistry because I did not take any chemistry courses in college. I did a couple biology classes, a couple physics classes, but I just avoided chemistry classes since I was not a science major and I didn't need a lot of science. But that's okay. You don't need to be big into science to be able to answer these questions, at least the ones that we will ask you. Because on these half-life questions, we will tell you an equation that tells you how many grams in mass of something you have. This one just is some made-up radioactive isotope. And if I want to know how much mass does he start off with, so initial means at time 0, you can just plug in 0 for T and solve. And you don't have to know anything about science other than to know initial means at the start when T is 0. Okay, well, this exponent, what's 0 divided by 2007?
0.
And what is 1/2 to the 0 power? Because anything to the 0 power is 1. So this guy starts off with 40 grams of mass. Now, the more likely type of topic that should come up in chemistry, I believe, or at least it will at some point, is how many years have to pass before it reaches half of the initial mass. That is what is half-life. How many years does it take for half of it to go away? So if 40 is how much you start off with, I would like to know when does it reach 20. So if I set this equal to 20, I can solve this for T. Now, most of the time, you need to solve for a variable that's in an exponent like this. We would have to get out some logarithms and do that. But we haven't reviewed logarithms yet, so this will be kind of rigged in a way where it will work without it. So if you start off by dividing both sides by 40, you get 1/2 is equal to 1/2 to the t over 2007. What is the exponent on this 1/2?
What?
So if this is 1/2 to the 1 and this is 1/2 to the t over 2007, do you see how the exponents just have to be equal? So how many years?
2007.
So if that function really represents how much mass that isotope has, then it would take 2007 years for it to lose half of its mass, to go from 40 grams to 20 grams. And then another 2007 to go from 20 grams to 10 grams. And another 2007 to go from 10 grams to 5 grams. So when does the radioactive stuff ever reach 0?
Wait, is it exponential?
It is. It's exponential because you've got a variable in the exponent.
Yeah, so you can't just add 2007 to 2007 and get the 0.
Half is gone.
Yeah.
So half, 2007 years, half of it's gone. Reset, another 2007 years, another half of what was left is gone.
Oh man, that's a long time.
So,
it'll never go away, right?
so it's never 100% going away. Correct. That's like, essentially, it's like an exponential decay. Like it can be close to 0 after a few times, but it's not ever going to actually reach 0. But the same thing's true, like certain medications you take. Medications you take have half-life. So something you took as a baby, there's next to none of it left in your system, but some of it's still in your system. And it will be forever. I mean, almost none, but still there's a little bit.
Alcohol?
I don't know about alcohol.
Alcohol's
Your liver can
I don't know. Okay, so notice worksheet 1 looks just like worksheet 2. Same question types, different function. So I would like you to try this one to see how you do. Again, I was trying to give you as much class time as I could here so that you didn't have to do much of this for homework. And you guys have 20 minutes, so I think you can finish it. The only question that you should be skipping on here for today is part O, because we skipped that same question type on the front. But on Friday, when I talk about that question type, you will need to go back and do those. I'm saying that a second time because every year there will be a few people who never do those, and then I will give them half credit on the assignment, and they'll say, I thought I didn't have to do them. You don't have to do them right now, but you will have to do them when I tell you that they're assigned on Friday. Okay, so please do that to the best of your ability. Try not to flip back and forth too much. Use the front page kind of as a guide as needed, but you really should probably mark those questions that you need a hint on. The website does have the answers so that you can check and make sure that you're actually doing them correctly. But I need you to do that between now and Friday because these question types will not be our focus on Friday.
Do you think I could leave like 5 minutes early? I need to go.
I can't. Talk to who?
She's leaving at this period because she like just comes for this period and then leaves.
I can't do
Just-
that. I'm sorry. You can step out in the hallway and talk to her if you need to, but I can't have you leave.
Well, she's like in a class right now, so I don't want to like go in the middle of her class.
Yeah, I can't have you leave 5 minutes early. I'm sorry.
feel like I saw somewhere that 0 to the 0 probably would be 1.
Yeah, I mean, I don't know. I know that's a math topic that is debated sometimes. I just don't,
Does it have
I've
an
never
actual-
looked into it.
I saw some dude do like a proof sometime
What the heck?
of it. Or it's kind of weird. What? No, I didn't do this. I actually didn't do that.
Well, Money, she's already entered and I went ahead and put yes on your Tuesday, you have to do a thing.
Great.
All my money for mine.
Is she in your class right now?
No,
Oh, okay.
the pre-calc kids, I had one.
No, I know, but I think I had her brother for
Oh,
like
she's so
2 years,
sweet.
calculus and algebra 2, so,
She's so sweet.
yeah, I just wanted to know if that was her
Oh.
brother or not.
Oh, that's good, she had an older brother.
Yeah, Ian.
Okay. Yeah, so, has anybody volunteered to go with you yet to this Saturday?
Nope.
I don't wanna. I'm like, I don't wanna.
I don't want to either, but
I know. so
I'm doing
just-
it next year if no one else is doing it,
Yeah, I know.
so.
Kelly said she told me she was not going to do it.
Yeah, I understand, like, it's not part of y'all's contract or anything, it's just
And
that we can't
It's
send
just
a
got a long ways.
We
It's
can't-
me, you, Ann, and Kelly, and Alex are the ones that really sending kids, right?
Alex had like 2, I think, this page.
That's all?
Ann's had a lot, but I think she said she has like, her kid has a
See, what
soccer
about-
game.
What about, Tyler, from Alpha Theta? He's getting a lot of these kids from Alpha Theta.
He is, he said something too, I don't remember what it was, but.
I could go if I have to. I'm just a last resort.
Yeah. Well, like I said, you don't have to. I'm not pressuring anybody. It's just that if we send 30 and send 1 proctor, I'm not gonna do it next year.
No, I wouldn't either.
Yeah.
I agree. I agree.
So,
So I'm just kind of playing it by ear to see if anybody else like jumps on it.
I don't know. Based on,
Who's sending
I
kids?
kind of understand. See,
What
Kelly.
about AP Stat? Is Meredith not even advertised? We have none going from AP Stat, do we?
No one's on there yet.
And
But she
they
did turn in some money for a student, but he's in calculus, and he made sure that she knew it was for calculus.
See, she should be really pushing those AP Stat kids
I
to go.
don't know, but it's.
Because I mean, it's not very many that compete. I don't feel like that as much.
That's right.
We might actually.
I don't know. See, I just don't know much about the AP stat.
I don't either. I don't know.
I was just plugging in.
How are
It was
you?
great.
Right
Yeah. This is my small class,
now? Okay.
but there's also a few kids out there. Guys, y'all are done?
Yeah.
Okay. It's one I've had.
Every one of them is like, got it done.
Wait.
Okay, we need to.
So,
Is he one of yours too?
no, he was in PSAT boot camp, but his little brother's name. Right, that's so close, so close. Anyway, his little brother was in, Caitlin, when she was teaching at Sunshine School, when she was little.
Yeah, so we need to figure out
She
what-
taught him at Sunshine School, and him and Will were friends, and they come to the house on birthday parties and stuff for your dad. Yeah,
Are you,
back in the day, in school.
did you start at 3.1 today?
I will tomorrow,
Okay.
yeah, I will tomorrow. So, we're on the same spot. And next week though, you only have 1A down next week, and I have 3. Did you see that schedule? That's so auto schedule.
I guess Diego's fine.
I think that's snow day.
We're trying to figure out.
Oh wait, no, that was a B day. That was a snow day.
We'll have to, if you wanna watch it, I'll just.
I don't know.
This way's been built the whole time, because Monday's a
don't know
holiday,
about
and
this
Friday's a
necessarily,
physical
'cause I
therapy,
can
I thought they would
You
change
know-
that age to.
You know
I
we're
thought they
keeping
made
the
that-
schedule next year, right?
Huh?
You know we're keeping the same rotation next year.
Like the AB, yeah. See, I would've thought that it said that when we were out on Monday, that automatically make that Friday an A day. They didn't, they made it a B day, like following this calendar.